Hey guys, wrapping up the week here with our day 7 video of secant tangent exterior angles. So just like yesterday, or the previous video, we have a secant and a tangent line again intersecting, but this time they're intersecting exterior to the circle. So let's take a look at what that looks like and see if it reminds us of any videos that we've seen in the past. So here we see a tangent line that's touching once, and we see a secant line that's touching twice. This kind of looks like the secant exterior. So my hope is this is going to work the same way. For a secant exterior, I said angle equals big bend minus little bend divided by 2. If that was the case, x should be 80 minus 30, which is 50. Divided by 2 is 25. But since this is different, we can't just assume that it works that way. So let me show you how we can prove that it does work the same way as the other one does. We're going to do this by connecting 2 points. I'm going to connect this tangent point to this intersection up here. When I connect those two things, a couple of things happen. Number one, I get a triangle. Okay, so we see that triangle. That's helpful because we know a lot about triangles. I also see an inscribed, I see an inscribed angle up here. So I'm going to be able to figure that out. And I see from our day 6 video, a secant tangent intersection on the circle. So just based on yesterday's video, I can figure out this angle. This angle has to be half of the bend. So I know that this angle right here is 40 degrees. Okay? I also know how to find the measure of that inscribed angle. Right? When we take a look, that inscribed angle intercepts this bend of 30. So I know that this angle has to be half of the bend. So this angle has to be 15 degrees. Then I'm going back to our old friend, right? If we think about this now, here's what I have. Yeah, that was terrible. Let me try that again. If I just focus on this triangle, x is here. I know this was 15, and I know this was 40. Now what I know is these two angles right here, x and 15, non-adjacent plus non-adjacent, has to equal that exterior angle of 40 degrees. So I know that x plus 15 equals 40. Which tells me that x equals 25, which is beautiful because that works exactly like secant exterior, right? Where I can do big bend minus little bend, 80 minus 30 divided by 2 is 25. Okay, just to confirm that that has to be true on all of them, let's do it with the letters. Again, with the letters, I'm just confirming that it works for any numbers. I know that this angle has to be z over 2 degrees. I know that this angle has to be y over 2 degrees. And x plus y over 2 must equal z over 2. So I get x equals z minus y over 2. And again, here's how I want to think about this with secant tangent exterior. Angle equals, once again, this should remind you of day 5. Angle equals big bend minus little bend over 2. Because again, x was my angle. Z was my big bend, and Y was my little bend. So let's do just a couple of examples here. Once again, I can put the unknown as the angle or the bend, big bend or the little bend. So let's just look at a couple here. Here's example 1. Again, if you look at your day 5 notes, these problems will look very similar because the equation works the same way. Okay, so here's a tangent line. Here's a secant line. They are intersecting outside of the circle. Okay, let's say this is 120, and this is 40. No, let's do, let me change that. Let's make it 30. So again, I'm following the formula. Angle equals big bend minus little bend over 2. All right, what's my angle? Well, the angle here is marked as X. So I'm going to put in an X for the angle. My big bend is 120. My little bend is 30. And I have to divide those by 2. Now, since X is already alone, all I have to do is simplify the right side of the equation. 120 minus 30 is 90. 90 divided by 2 is 45. Easy. Take a look at another one. And here's my tangent line. Here's my secant line. This time I'm going to tell you the angle is 30 degrees. I'm going to tell you the little bend is 50 degrees. I'm going to ask you to find that big bend. So when we see this, we follow the same formula, but my unknown isn't the angle this time. My unknown is the big bend. But the setup is the same, just X will be in a different place. Again, I always start angle equals. Angle here is 30. Big bend, X, minus little bend, 50, over 2. Now, how would I solve that? Well, you should be used to it by now. I'm going to multiply both sides by 2. I'm going to get 60 equals X minus 50. And I'm going to add 50 to both sides to get X by itself. And I get 110 equals X. Because 110 minus 50 is 60. 60 divided by 2 is 30. All right, last example, and then we'll be done for the week's worth of videos. Here's my tangent, my secant. I'm going to say this one is 15 degrees for that angle. I'm going to say I don't know my little bend. And I'm going to say my big bend is, I don't know, let's say 100. So once again, I can solve this by saying angle equals big bend minus little bend over 2. What's my angle? My angle is 15. That has to equal my big bend of 100 minus my little bend of X over 2. How do I solve this thing? Well, I'm going to start by multiplying by 2 on both sides. And I'm going to get 30 equals 100 minus X. I'm going to add x to both sides, and I'm going to get x plus 30 equals 100. Then I'm going to subtract 30, and I'm going to get x equals 70. So my little bend ended up being 70 degrees. All right, that's it for this one. Have a great weekend, and I hope to see you guys soon. Hang in there. Stay safe. Wash your hands. And be well. Talk to you guys later. Bye.